Alright, in today's problem, I'll talk about job processing. So in this problem, we will just use a greedy approach to solve this problem by first calculating the time required to complete the type A operation on each of the jobs, and then we will add the time required to complete type B operations to those jobs. And so first here, we're reading the input. I created this array T to keep track of some of the specs of the machines. So this first parameter here will keep track of which machine this is. So 0 will stand for machine A and 1 will stand for machine B. And the second part will keep track of two things for each of these machines. 0 will stand for how long it's required to complete the job using this machine, and the other one will keep track of how many the time already used for this machine, and this last one will just keep track of each machines with a maximum of 30 machines. And so here we'll receive in this T00, so this means that we're doing machine A, and this second 0 represents that this is the time required for machine A to complete a job, and this 1 will first be set to 0 because we haven't used this machine yet. And then this is the same thing here, but this time we're reading the machines that perform operation B, and so we change this to 1 instead of 0. And here we'll just create this new array called wait. So this wait will keep track of the time required to complete a few number of jobs. So in total we have to complete n jobs, and so we'll loop through this each, and we'll use this getMin function, which I said here. So this will also reading which machine we're doing, machine A or machine B. So here we use 0, which means machine A, and we'll get the one with the smallest time. We'll get the machine that have the smallest time that currently has the smallest time, and so to get that, we will add the amount of times the machine needs to complete this job, and also the current time that are already used. And so we have to get the minimum for this one, and if it is smaller than our current minimum, which starts at int max, then we'll set our optimal answer to this, which is the time required to complete it plus the current time. So this will increase, and at the end we'll increase this current time by the time required. So now this means that we've used up more time on this machine, and next time we go through this loop, we will find another machine that has a smaller sum for this, or maybe it can still be the same machine because the machine can be pretty quick in processing the jobs. And here we'll return the minimum. So this will give us the minimum time required, and so we'll set this to each of the 0 to n, and so at the end, just wait n minus 1 will be the answer. Will be our first answer, the time required to complete all type A operations on the n jobs. And then here we'll use this to get the best time required to complete all of the jobs, which is also including type B operations. And here we'll basically use the same thing, but now we have to add the amount of time that is needed to complete operation A first, because we cannot do operation B until we finished operation A on this current job. But here I will sort the jobs in reverse order instead, because we want the first, since each job with the smaller number will be completed earlier, we want the job with the last one to be completed as fast as possible for type B, and the first job should be completed with the slowest but also optimal time for the type B operation, because this way we will first, at the earlier times, we will first start processing job type B for job A, and we want to make it so that at the time we're processing job B, we're processing the final job, we want to make sure this will end as quick as possible. And so this is why we have to do this in reverse order. So here we will add our current wait time required for that. So this wait time is the amount of times that we need to wait for all of those operations to complete, so we can add this current time B into our previous weight answer. And here we'll use getMin, but this time we'll use machine type B instead of type A, which is 1. And so we'll compare our answer and get the maximum, because we know that this is already the optimal move, but there might still be an one of them will still have the greatest time required, and so we will set the time required for this total process to the maximum of the sum. And here's an example. For example, here, if we process the job using what we did here, for example, for task A, we could have these few numbers, and for task B, we can have these few numbers. So actually in the beginning, we will loop starting at the last job, and then go back to go down to the previous jobs. And so this is why the last job has the optimal time for task B. And so here, by the time we complete task A, which the first job, and this task A will only take 2 minutes. And so by that time, we will start processing task B for this first job, and in total this will take 7 minutes. But here, the last job requires 17 minutes to complete for task A, and for task B, this is why we have to minimize this. So then the task will be completed as fast as possible when we are actually on this final job. And so here, the maximum will be those two added up together, which is 18. So, but if you do it in the reverse order, which is 1, 2, 3, 4, 5, then here at the end you're going to have 22, which is bigger than what we want. And so this is why we want this task B at the last to be smallest as possible. And then finally here, we just have to print out the answer. First, we print out what is the time required to complete all of the task A, and that is just the amount of time that we waited to complete task A for the final job. And then the second one is the time required to complete all task B, and this is what we find here, the maximum of the sum.